All right, so my name is Maciej Lewkowicz. I'm a full stack developer at Kiwi, and I'm here to talk to you about running Magento 2 on Kubernetes. So first things first, what is Kubernetes? Well, it's an open source system for automating deployment, scaling, and management of containerized applications. But for the next 30 minutes, for our purposes, let's think of it as a middle layer between pods, which represent workloads, and nodes, which are the actual machines, either physical or virtual. So why would you want to use Kubernetes? Well, the usual benefits are, of course, the automation. Everything is automated there. Also, you get very nice scalability, and this also means efficient resource usage. So your servers don't sit idle most of the time. However, for us, what tempted us to go with Magento 2 on Kubernetes was the ability to use containers all the way. To have the same stack, to have precise versioning, so exact same version and configuration of each service on local dev and staging. And this also helps with the move towards immutable infrastructure, where you don't modify your resources, but rather tear them down and start new ones with the new configuration. And also infrastructure as code, which means that you store your infrastructure information in the repository. So the plan for today is to get a cluster, create the container image. This is where Magento will live, as well as deploy the whole thing and see what happens. So the cluster. For local testing, there are multiple options. So if you're running Mac or Windows, you can use Docker Desktop. Also, Minikube is a good option. It works on all operating systems. Of course, there are also other if you want to get more experimental. For the actual servers, you could either use a cloud provider, one of the big ones, or maybe one of the smaller ones. They all provide managed Kubernetes clusters, or you can go the self-hosted path, so deploy your own. That's up to you. So let's assume we already got the cluster. We need to prepare the container. For the container, we need to make sure to double check the tech stack requirements for Magento, as well as software and hardware recommendations. So this way we make sure that we have all the PHP versions, modules, configurations, everything like that in order. And also we will follow the 12-factor application manifesto for this particular setup. This will basically make everything easier to operate. So the 12-factor app manifesto, as the name suggests, it's 12 things that it's very important in our case to think about when creating the container. So let's try to go through them one by one and see how it relates to the actual image. So number one, code base. We want one code base tracked in revision control and many deployments. This basically means that we will have one version active at all times, and we will use it everywhere. So to achieve that, we need to bake everything into the image. This means source code as well as composer dependencies, but also compiled code and generated assets. Number two, dependencies. We need to explicitly declare and isolate dependencies. We get this in Magento by design, which is very nice. We just need to make sure that composer dependencies are installed into the image, as well as that we have installed PHP modules, any system dependencies that are required. For number three, the configuration. We want to store configuration in the environment rather than configuration files. This is very slightly tricky, however possible. So we'll need to add config PHP to the image to make sure that we can run code compilation and static assets generation, as well as the env PHP file. However, please note that this is a modified version, so we do not bake in actual credentials for the database and other services in the image, but rather we use this small PHP trick to be able to get them from the environment. Next, we need to treat backing services as attached resources, which basically means that we run the database, Redis, and volumes separately. So the container image needs to contain only the application, no storage, basically. So all storage is attached from the outside. For number 5, this is the important part and one of the reasons to use Kubernetes as well. So to strictly separate build and run stages. So here we need to make sure that, again, compilation is run during build, as well as that static files are generated during build. And the third thing that will come up later is to avoid long initialization. So ideally, the container image should start in a matter of seconds, and then we have a new running instance of Magento. For number 6, we want to execute the application as one or more stateless processes, which, again, we get by design. Just need to make sure to use Redis, and then everything runs as a separate process. We also would like to have, we would also like to export services via port binding, which is the tricky part. So how can we do that for a PHP application? If we won't be very strict and do it by the book, we could try doing something like exposing ports at application level, which is possible with PHP, with libraries such as React PHP. However, this gets very tricky with Magento. I'm aware of one attempt to do so, but it was 4 years ago, and I don't think much was done. Another option would be to expose port 9000, which is PHP FPM. This is, well, this looks like a nice idea. We could have single process in the container and scale the web server and PHP independently. However, this involves unnecessary complexity. So instead, we'll just treat the web server and PHP as one part and include the server and the PHP in the container. It's simple, it works. It doesn't matter if you run Apache or Nginx, ModPHP or PHP FPM. It's actually okay to run multiple processes in a single container. However, make sure to separate applications. So don't run 2 applications in the container. If the application by design consists of 2 processes like Nginx and PHP FPM, then it's fine. Okay, so moving forward, we would also like to scale out via the process model, which basically means that we need to be able to scale horizontally. And for that, again, make sure that everything is into the image. This will be important for quick startup, and also use Redis to be able to share sessions between different containers. Next up, this is related. We want to maximize robustness with fast startup and graceful shutdown. So again, bake everything into the image, make sure it starts very fast, avoid any unnecessary initialization steps. For number 10, this is one of the reasons why we want to use Kubernetes. So we want to keep development, staging, production as similar to each other as possible. Actually, we can make them almost identical. So we used same images, same configuration, same workloads, just scale everything down, because for production you need much more resources. So instead of running, say, a dozen instances of Magento, for staging is probably okay to run 1 or 2. For number 11, we want to treat logs as event streams. This is again very important. This allows us to get logs from all containers in Kubernetes. So the logs, in order to be saved and processed, they need to make it to standard out or standard error, because that's where all the tools expect the logs to be. And for that, we have 2 options. Either use monolog to log to PHP standard out, which should make it to the container standard out, or if for some reasons you need a lazy solution, just create a sidecar container and print everything from files, from Magento log files to standard out. What's a sidecar container? Well, it's just a container that runs next to your main application. And it's concerned with running some peripheral tasks. So in this setup, the main container would be Magento, and sidecar would be just a very simple script that reads Magento logs in real time and puts them to standard out so that they can be used by the tooling for further processing. Okay, and last but not least, we want to be able to run administration management processes as one-off processes. For that, we'll need to make sure that we can use the same image for everything. So web, cron, queue, consumers, any one-off tasks that we might need to run. And well, basically this has us covered. So to summarize the container part, we really want to include everything in the image. So all the dependencies, all the compiled code, all the static assets. Also make sure that you can use external storage, database in Redis, of course, but also volumes, so that volumes can be attached to the container for example, media storage, and ensure fast startup. So to do that, use the modified env PHP file so that the configuration can be read directly from the environment, rather than having any initialization steps that would write to the file. Okay, so having covered the container, let's get to the fun part, and this is the deployment. So the deployment, we have 4 things to do for that. We need to plan what we want to deploy. We need to get the tools, create some manifests, and deploy the whole thing. So the plan is to deploy the standard Magento architecture. So the standard architecture looks something like so. So we have the Magento web container in the center. Of course, Varnish in front for caching, and the reverse proxy in front of Varnish for TLS termination, as well as various plugin services on the other side, so database, Redis, Elasticsearch, so on. And we have 2 more services that are not exposed to the public. This is the Magento consumer and, of course, cron. For Kubernetes, we have the exact same setup. The only difference is that the reverse proxy will be called an ingress. Okay, so having prepared the plan, let's get the tools that we need for the deployment. We'll use 2. We'll use kubectl, which is the standard tool for controlling Kubernetes clusters, as well as Kustomize, which is a very nice tool. It's a template-free way to customize application configuration. It's also built into kubectl. However, you might want to have a standalone version on hand, just in case there are any problems. Okay, so having the tools in place, it's time to start writing the actual manifests. So what are the manifests? Everything in Kubernetes is a resource. So all objects are resources, and manifests describe them. So manifests describe what you want to have going on in your cluster. For resources, we need to be aware of 4 basic types. So pods are not containers. Pods actually encapsulate containers, 1 or more containers plus the environment, so the context in which the container runs. We have workloads. Workloads control pods. We don't really want to control pods directly. We need to have a layer of abstraction on top of that. And that's what different kinds of workloads are for. Deployment, stateful set, cron job are only the 3 popular ones that we're going to use. There are plenty more, so make sure to check the docs for your special needs. And for the last 2, we have services, which are used to expose pods internally to each other. So they basically provide connectivity between pods, as well as config maps and secrets, which are used for storing, well, configuration and secrets. And again, just one thing that I want you to bear in mind for the rest of the presentation. The pod is the basic building block. This is where the container runs, but the pod is controlled. The pods are controlled on the one hand by deployments or stateful sets or other types of workloads. They control whether the pod will exist at all. And on the other hand, we have the service. The service describes how to connect to the pod, like which ports are open. It connects the pod to the other pods inside the cluster. Okay, so for the actual manifests, let's start writing them. Let's start with the application manifest for Magento. Each manifest consists of 3 parts. First, we have the kind and API version. This describes what kind of resource we want to describe. Next, we have the database, the metadata. The metadata consists of name, namespace, labels, stuff like that. And the spec, which is the actual content of the manifest and describes what's going on in the resource. So for the application manifest, we just have created the service. We also need the deployment. This will run the pods. We can have multiple resources grouped into a single file, just separated with triple dash to make sure that they are treated as separate, resources. So for the application, we'll use a deployment. This is a very basic workload, and it provides declarative updates for pods and replica sets. Replica sets are a layer between pods and deployments. We don't really need to worry about this too much. We don't need to control replica sets directly, just focus on deployment. And again, the important part, the part where everything gets configured, is the template part of the spec. This is a pod template, so this is where we describe what we want deployments to be running. Also, because we're using customize, we need to create the entry point, the main customization YAML file. It just provides pointers to other resources for now, so the other manifests. Okay, to deploy the whole thing, just run kubectl apply -k. This instructs kubectl to use customize. If there are any problems, try standalone version. So build first and then just apply the generated manifests. Okay, next up, we need some volumes. To have volumes attached to containers, we need to first create them. Volumes in Kubernetes are controlled by persistent volumes, by the persistent volume type resource. So these are the actual resources in the cluster, the actual storage, and we also have persistent volume claims, which are claims on resources that we want to request for a given pod. Usually the actual volume will be automatically created for each persistent volume claim that you define. So we don't need to worry about them for now. Just focus on the claim. And of course, once we have the claim, we need to mount it to the actual container. So just provide the information about the path and which claim you want to use on the pod. Right, next we need to enable the internet to access our application. For that, we use an ingress. So an ingress exposes HTTPS endpoints to services within the cluster. This is the whole ingress manifest that we're going to use for now. Just bear in mind that this is used for load balancing, TLS termination, routing virtual hosts. So it's very similar to a regular reverse proxy you might have on the server. Next is the database. For the database, we want to use stateful set, which is like a deployment. It uses the identical spec for the pods. However, it gives us more control over how given workload is deployed. So it maintains sticky identity, which is important, and also makes sure that volumes are always attached to a particular pod. We also need to let Magento know where to find the database. So for that, we'll generate a config map. Here we use config map generator. This is part of Customize. It's just a wrapper that converts env files to config maps and mount the actual values to the container from the config map that we have just created. Also, we can define environments directly in the manifest rather than through the config map. This is handy for connecting services. So here we just provide the values for MySQL host and port directly from the service.
Okay, I want to say that we have 5 minutes left until the Q&A session. Please make sure to wrap up. Thank you.
Sure, thank you. Okay, let's do the same for Redis as we did for MySQL. Make sure that it's connected to Magento, so Magento is aware where to find it. We do basically the same for RabbitMQ. When it comes to the consumer, the queue consumer, just copy the app deployment, provide the custom command. That's why we wanted to use the same image for everything. That's in practice how you actually do that. Going further, instead of directly creating resources such as deployment stateful sets and so on, we can use an operator. This is just a layer on top of the native resources that controls their existence. So for Elasticsearch, we can use Elastic Cloud on Kubernetes created by Elastic themselves. This is how you deploy Elasticsearch. So instead of defining deployment stateful sets and so on, you just create a new resource called Elastic, tell it which versions you want to use and so on, and it will handle the rest. For cron jobs, we are using native Kubernetes cron jobs, which are just creating a new pod for each run every minute, run the command, and then exit. Important part here is to make sure that you disable separate processes for different kinds of cron jobs. Otherwise, the containers will be terminated prematurely. And yeah, that's pretty much it for the deployment. This is almost the whole customization YAML that you need to deploy Magento, the whole stack to Kubernetes. It's, I think, not very much. I've also added Varnish, which follows the previous steps that we used just for Varnish. Again, to deploy the whole thing, just apply. And yeah, to summarize, customization YAML is the entry point. You can group manifests into files by application. You don't need to store them separately. There are tools for managing stuff like config maps from files directly, so they can be used, for example, by Docker Compose for local development, the same set of config files. And also make sure to use the same image for different kinds of workloads. And yeah, we're done. We have the cluster, have the container image, have deployed everything. That's it. Or not necessarily. We also need to take care of a few things. I'll get through them very quickly. So we need to figure out log management. This is usually taken care of by the provider, but you might want to deploy your own ELK stack. You can define jobs for stuff like setup upgrades. Just make sure not to deploy static content using jobs. We need this at the build stage rather than the run. We also need some monitoring. This is, again, provided by the cloud provider. Otherwise, you can use Prometheus. Once you have monitoring, you might want to allocate some resources to containers, define requests and limits, which is just adding a few lines to the manifest itself. Once you have that, you might want to look into auto-scaling. That's why we wanted to make sure that the containers start quickly. For auto-scaling, you just create a horizontal pod autoscaler, give it some rules. This is the whole thing. It will scale based on CPU usage. Going further, you can use node autoscaling as well. This is dependent on the provider. And the last thing is make sure to look into customized overlays. They make handling differences between dev staging and prod way easier than just creating separate manifests. And yeah, if you want to read further on the topic, I invite you to read my article where I describe in more detail how to approach Magento 2 deployment in Kubernetes. It's on our blog. Also make sure to check out 12-factor as well as Kubernetes and customized docs. And we're done. Thank you. I can't hear you. Are you muted?
Can you hear me now? Yes, thank you very much. Yes. I've been talking for so much time. Thank you very much for your presentation. We have quite a few questions already, and we have very active listeners here. For some of your questions, we already have responses here in the chat from Anna Savichka with your blog posts responding back. So if you don't mind, I will ask the questions that are not, I guess, covered with your blog post, at least at the moment. Maybe you will share more. So one of them is how the load is balanced in configured in Kubernetes and replication of PHP containers works.
So the load balancing is achieved on the ingress level. So ingress makes sure to route requests to different containers. And then we use auto-scaling to make sure that we have enough of them, enough of application instances to handle the current load. And yeah, it's automated. There are, I'm sure there are ways to customize it to have more control over that somewhere in the Kubernetes docs, but on the most basic level, it's just routing traffic to multiple instances of the Magento deployment. And if you add the horizontal pod autoscaler, also making sure that you have enough instances to handle the load.
Thank you. We have a few questions from Stanislav. I will read all of them. Maybe you will find a way to group and have the answer for the bulk questions from him. How long does it take to deploy? Why don't you run consumers on the cron instance? And how do you prevent cache overriding and collisions in shared Redis during deploy?
Okay, so maybe let's start from the end. When it comes to cache collisions, we never really had them with Kubernetes. Well, when deploying, you basically do the same thing as if you would do for multiple servers. So running multiple Magento instances on multiple servers. It's not very different from that. The second question was about consumers.
Yes.
Yes.
We have 1 minute left, so I would appreciate you responding back to this question. And then we have a very good suggestion from Anna. Why don't you run consumers on the cron instance?
So we basically want to have them separate so that they also can be auto-scaled. And rather than controlled via cron, we give control to Kubernetes so that it can handle, make sure that they are running basically, and we have enough of them to handle the tasks.
Thank you. We have a suggestion from Anna so that you can have the follow-up and Google Meet with everyone who's interested in this topic to learn more. She has shared your email here. So guys, feel free to reach out to Maciej or either via the email or maybe here in the chat room. We're going to have the networking session available. Thank you, Maciej, for an interesting presentation. You can see how many questions we already have. So it is actually a trending topic. Guys, feel free to have your 5 minutes break and make sure you get on time for the next presentation because we have also a lot of information heading to you. Thanks a lot and enjoy the conference. Thank you, Maciej, once again.
Thank you.